Hello pre-calc students. Today we're doing a lesson on the components of vectors, and we'll throw in dot products. So let's get started right away. Remember, a vector is going to have both magnitude and direction. Another way to describe a vector is by its vertical and horizontal components. So let's break this down using this example of a vector. A plane flies 600 miles at an angle of 50 degrees north of west. How far north did the plane travel? How far west? First of all, we need to find 50 degrees north of west. So if this is west, we're moving 50 degrees north of west. So this angle right here is going to be 180 minus 50. So 50 degrees north of west, that's going to become 130 degrees. So our direction is 130 degrees. So now let's find our vector. Our angle is 130 degrees, and our magnitude is 600. So we need to find the vertical and horizontal components. So we have a horizontal component and a vertical component. All right, so X is the horizontal component, Y is the vertical component. And what we need to do is know that the direction is 130, the magnitude is 600. And we can get our calculator going and use trig to find our values. All right. So now that I have a calculator up, I know that if our angle is 130, we know that the cosine of 130 is equal to adjacent over hypotenuse. So x over 600, which is the hypotenuse. So 600 times the cosine of theta is equal to x. And 600 times the sine of theta is equal to y. So get my calculator, make sure my mode is in degree mode. And to find x and y, I can find the horizontal components. So I can find 600 times the cosine of 130. That's going to be negative 385.67. And that makes sense because we're moving west from the origin right here. So you are moving in a negative direction. So you have an x component of negative 385.67. That is our horizontal component. This is so we traveled west 385.67 miles west, and then 600 times the sine of theta 600 times the sine of 130 means that we traveled 459.63 miles north. So 459.63 miles north. And that is our answer. Okay, so notice we've used trigonometry to find the horizontal and vertical components of our vector. And like coordinate points, the component form of vector is listed the horizontal components first, then the vertical component. Instead of parentheses, vectors use triangle brackets. So given the vector in component form, give the magnitude and compass direction of each. So if you think about it, this would be the horizontal component is -3. So -3 is the horizontal component. The vertical component is 4. So this would be the vector right here. And that has a value of -3, +4. So that's what it would look like. So to find the magnitude, we can use the Pythagorean theorem. So we can say -3 squared plus 4 squared is equal to the, let's say m is equal to magnitude, m squared, so 9 plus 16 is equal to m squared, 25 is equal to m squared, so your magnitude is 5. And then your direction you have to find theta. The tangent of theta is going to be equal to 4 over -3. So theta is going to be equal to the inverse tangent of 4 over -3. So we find the inverse tangent of 4 over -3. That's going to be -53.13 degrees. But this is in quadrant 2, right? Because when the x is negative and the y is positive, this is in quadrant 2. So our quadrant 2 angle, when theta is equal to -53.13 in the calculator, that means to find it in quadrant 2, we can just do 180 minus 53, because for our tangent of theta, if this angle is going to be equivalent, this reference angle is going to be equivalent with, if we draw a unit circle, with that angle, okay? So that's going to be 180 minus 53. So you're going to have 180 minus 53.13. 180 minus 53.13. So our angle is going to be 126.87. So theta is equal to 126.87 degrees. And we also know that we could call this, we could also call this 53.13 degrees north of west. So this is the solution for theta, all right? Let's break it down for the next example. All right, I'm going to be a little bit quicker here. This is going to be the square root of 5 squared plus negative 2 squared. That's equal to our magnitude. So find the square root of 5 squared plus negative 2 squared. 4.58. So magnitude is equal to 4.58. And remember, if x is positive and y is negative, when x is positive and y is negative, we are in quadrant 4. So theta is going to be equal to the inverse tangent of negative 2 over 5. So pull up our calculator. We find the inverse tangent of negative 2 over 5. And that's going to be equal to negative 21.8 degrees. So that means theta is going to be equal to negative 21.8 degrees. So we can say for our direction, we could say we are, and this is a quadrant 4 angle. So we can say we are 21.8 degrees south of east, or we can say theta is 360 minus 21.8. And so we do 360 minus 21.8, and that's equal to 338.2. All right, let's keep going. All right, to add and subtract vectors, you add all horizontal components and vertical components separately. To multiply a vector by a scalar, which is a number, just multiply each component by the scalar. So to find u plus v, we can do the vector would be 3 plus 11, comma 3 plus 8, which would give us a value of 14, comma 11. That would be adding the two vectors. All right. Now we need to do 4f minus 6v. So 4f, we do 12 times 4, 12, 24, 48, and 4 times 2 is going to be 8. 6v is going to be 6 times 2 is 12, 6 times 4 is 24, and then we're going to subtract it. So when we're subtracting the two, we're going to have 48 minus 12, comma 8 minus 24. So we will ultimately have, for 4f minus 6v, components of 48 minus 12, that'll be 38, 36, and 8 minus 24 will be negative 16. So that's how we add and subtract vectors or multiply by a scalar. A plane flies at an angle of 40 degrees south of west. So by the way, 4 degrees south of west, that's going to be 180 plus 40, so that's going to be 220 degrees. The wind blows 35 degrees east of north, so that's going to be 90 minus 35, which is going to be 55 degrees at a speed of 40 kilometers an hour. What is the resultant speed in the direction? So we can draw the vectors on the coordinate plane, convert the compass. So I want you to try to draw this, visualize for yourself. Convert the compass directions to a degree out of 360. We just did that. Use a cosine for the horizontal components and sine for the vertical. Redraw the new coordinate plane. Use a Pythagorean theorem and the tangent to find the magnitude and direction. Okay. So the horizontal components. This is going to be 300 times the cosine of 220 plus 40 times the cosine of 55. The vertical components would be 300 times the sine of 220 plus 40 times the sine of 55. So we just need to add these up. So the horizontal components are going to be 300 times the cosine of 220 plus 40 times the cosine of 55. The horizontal component is negative 206.87. Negative 206.87. And the vertical component is going to be 300 times the sine of 220 plus 40 times the sine of 55. So it's going to be negative 160.07. Okay, now that we have our horizontal and vertical components, what we can do is we can use the Pythagorean theorem and the tangent theorem. So the magnitude is going to be equal to the square root of negative 206.87 squared plus negative 160.07 squared. So negative, so we're going to find the square root of negative 206.87 squared plus negative 160.9 squared Well, it's I entered that in wrong. Okay. Here, you can just turn the values positive. So we can find the square root of 206.87 squared plus 160.9 squared. So that's going to be 262.07. That's the magnitude. It's equal to 262.07. So make sure you can put your negatives in parentheses. That way you don't mess up the calculator. And the direction is going to be the inverse tangent of negative 160.07 over negative 206.87. So we find the inverse tangent of negative 160.07 divided by negative 206.87. So that's going to be 37.73 degrees. So the calculator output, that's going to be 37.87 degrees. But if you see this, it's x value is negative, y value is negative. So this is quadrant 3. So the quadrant 3 equivalent angle with this is going to be 180 plus 37.87, because this is our angle. This is also our angle. That's the reference angle. So we do 180 plus 37.87, and that should be 217.87. So our direction is going to be 217.87 degrees. So we have 3 examples. I just want to get through dot product. We're going to do the other 2 in class. So a dot product is when you multiply 2 vectors, and the result of a dot product is not a vector. The result of the dot product of 2 vectors is not a vector, but a scalar. So u1, u2, and v1, v2, when you multiply them, that's going to be u1, v1 plus u2, v2. All right? Let's find the dot product of vector u and vector v if u is 5, 12 and v is negative 3, 2. So this u times v is going to be equal to a1 plus a2 plus b1 times b2. So let's do the math. This would be equal to 5 times negative 3 plus 12 times 2. This would be negative 15 plus 24. And this is going to be equal to 9. U times v is 9, and that is our scalar. It's a real number. All right. Another is we're using this we can just say that the absolute value of u squared is equal to u times u. So using this property. So the absolute value of u squared is going to be equal to 2 times 2 plus negative 4 times negative 4. And because of that, we're going to have absolute value of u squared is equal to 4 plus 16. So absolute value of u is going to be equal to the square root of 20. So absolute value of u is going to be equal to 2 root 5. All right, those are examples. We're going to do the rest of them in class. All right.